We store the source code as a simple string and we have a list ready to fill with tokens we're going to generate. The aforementioned loop, the dash dot, looks like this. So list tokens, so the tokens we defined earlier, then scan tokens. So these are add after the scanner. So first we create a scanner class. So it has a private string source, and then the list token equal new array list, and then scanner string source this dot source. So we are getting the data of this from the token we have earlier, and then here we define a function scan tokens and then call it inside. So we're basically doing a recursive call, and then tokens that add new token. So whenever we encounter a new token, we add that. So here is the full picture. So import static com. So we imported a token type util.map. So we create we import the list, the array list of Java. So there's a lot that happening there because we import a lot of third party and this token type we created earlier. So this is the start of us scanning those small sequence of Lexim. So the scanner works its way through the source code, adding tokens until it runs out of characters. Then it appends one final end of file token. So here that isn't strictly needed, but it makes our parser a little cleaner. So these are actually basically saying that hey, this is the end, kind of like a ritual that allow us to be clean with our implementation of scanning the smallest sequence of characters, which is the lexeme. So these loops depends on a couple of fields to keep track of where the scanner is in the source code. So this loop, the while loop, depends on this private int start of the file equals 0. So this is here private final list token, which is what we created in here. So here we added that variable int current. So as you can see, we need to track the start, the current, and the line. And the start at 0, current start at 0, private line start at 1. And then before the scanner string source. So the start and current fields are offset that index into the string. The start field points to the first character in the lexeme being scanned. So it's not actually pointing at the start of the file. So let me correct myself. It is pointing to the first character in the lexeme being scanned. So it's talking about this small sequence of character, and current points at the current character currently being parsed or processed. Then the line field tracks what source line current is on, so we can produce tokens that know their location. So the private int line start at 1 because this is a location tracker, whereby it track after it parse the current so that we know the location of that character we parse. Then we have, so that when it comes to error and then when it comes to making meaning out of that code, we can use that location. Then we have a little helper function that tells us if we've consumed all our characters. So we would add this add after scan token here. So private boolean is at end, then return current is greater than equal source dot length. So as you can see, if it's greater than or equal source code length, then this helper tell us that we've consumed all our characters, so that we can tell the compiler that we've done the parsing. So as you can see as well, we have multiple code in tracking the location of where our character is in the file. First, earlier we have in Lexim, we have the location. Now here we have private int line equals to 1 because this is important for us to make meaning specifically intended by the program for them to produce infinite expression like we discussed in a context-free grammar. Recognizing lexims, in each turn of the loop, we can scan a single token. This is the real heart of the scanner. So in each turn of this loop, we can scan a single token. So there is an ability to scan a single token using this turn of the loop. So this is the real heart. So we'll start simple. Imagine if every lexeme were only a single character long. All you would need to do is consume the next character and pick a token type for it. Several lexemes are only a single character in LOX, so let's start with those. So here are the class we created earlier. These are the private boolean that help us to see the end, the private. But now here, we created a private void scan token. So this private void scan token, we will add this after the scan token function. So wondering why isn't in here, don't worry, we'll get to it. So another subtle part of this is that, as you can see, we could start with multiple characters in scanning, but since we're doing a baby steps, one step at a time for us to understand, we're starting with characters. So we're starting with characters at a time, or the characters that we can parse, so that we can understand better what we are actually creating, spitting out token using that while loop. So as you can see here, left parent, left brace, right brace, comma, dot, those are the single character we will parse. Again, we need a couple of helper methods. Here, private char advance, then return source the char at current plus plus, closing, then private void add token, then token type. Inside is add token parameter type, comma, null, closing, then private void add token type, comma, object literal, inside string text equals source that substring parameter start, comma, current, closing, then tokens that add parameter new token parameter type, comma, text, comma, literal, comma, line. So here is the scanner.java and add after is at end boolean. So we will add this after is at end. So this is now the So this is how the code will look like. So here private char advance. So add it after is at end. Here is the is at end, right? Start token. We are at the beginning of the next lexeme. Start equals current, then scat token, then private char advance return. So we will add that inside of this code. So as you can see, it's inside the while loop. So we're handling that because we will start with looping with each character. So that's parts of the while loop. So the advance method consumes the next characters in the source file and returns it. Here, private char advance and then return it. Where advance is for input, add token is for output. So the advance is for input for our parser, and then the add token is for output. It grabs the text of the current lexeme and creates a new token for it. So it grabs that character, the right variant, and then create a new token for it. Now we'll use the other overload to handle tokens with literal values soon. So here we created an overload private add token for object literal, just so we can provide you a glimpse of how we would do with multiple characters, with parsing multiple characters. Lexical errors. Before we get too far in, let's take a moment to think about errors at the lexical level. What happens if a user throws a source file containing some characters Locks doesn't use, like at, hashtag, upper quote, starting quote, at our interpreter? Right now, those characters get silently discarded. They aren't used by Locke's language, but that doesn't mean the interpreter can pretend they aren't there. Instead, we report an error. So here, add this after this scan token. So we use a switch, right, in parsing. So we created the advance in each while loop first and then advance on each character before we define the switch case for each of the add token, and then single character, then break, and then after that we add this error message. So default, then locks that error, parameter line, unexpected char, closing, then break. So here we add that default here in the private void scan token. So note that the erroneous character is still consumed by the earlier call to advance. That's important so we don't get stuck in an infinite loop. So we need to still scan that erroneous character. It's important so that once we recognize that, we could stop the loop. Note also that we keep scanning. There may be other errors later in the program. It gives our user a better experience if we detect as many of those as possible in one go. Otherwise, they see one tiny error and fix it only to have the next error appear and so on. Syntax error whack-a-mole is no fun. Don't worry, since had error gets set, we'll never try to execute any of the code, even though we keep going and scan the rest of it. So even though we have, had error get set, we will never execute that. We will just scan that for error purposes. So the code reports each individual invalid character separately. So these shotguns the user with a blast of errors if they accidentally paste a big blob of weird text. Coalescing a run of invalid characters into a single error would give a nicer user experience.